Hi, 6th graders, it's Mrs. Gall. Today we're going to talk through Pythagorean Theorem. Get a fresh page in your notebook and put this title at the top. When you're ready to continue, press play. You don't need to write this, but just a little history on what we're going to talk through today. The Pythagorean Theorem is named after the ancient Greek mathematician Pythagoras, who is credited with recording its first proof. Pythagoras lived from 570 to 495 BC. It is often argued that the idea predated him. Mesopotamian, Indian, Chinese, and possibly Babylonian mathematicians also independently discovered the theorem. There are many ways to prove the theorem, and it potentially has more proofs than any other mathematical theorem. So this is a very old theorem. There's many ways to prove that it works, and today we're going to talk about what it is and how it will help us in geometry. First thing we want to start with is a little vocabulary. So this is a right triangle. I know it's a right triangle because I see that 90-degree indicator in a corner there. The two sides that make the 90-degree triangle, or that make the 90-degree angle, are considered legs. So this is one leg and this is another leg. And then the line that runs that diagonal that connects the two legs is called the hypotenuse. Go ahead and get that in your notebook for me now. Today we're going to talk through the theorem, and this is kind of a why this is going to work. So you're going to see a right triangle here, and on the right triangle, the legs, a square is drawn off of each of the legs, and the hypotenuse has a square drawn off of the side of it. So you're going to see how the two sides of the legs are going to start with the water, and as they rotate the wheel, the square going off the hypotenuse will fill perfectly with no liquid left over in the other two squares. So let's watch this here. So there you can see the legs start with all of the water, so that's those sides squared. And as the wheel gets turned, all of the water starts to go into the hypotenuse square. And it's just perfectly going to fit. So the legs squared completely fill the hypotenuse squared with nothing left over, which is why our theorem a squared plus b squared is going to equal c squared. Write this down now. The A and the B are going to be our legs, the two sides that make the 90-degree angle, and the C is going to be our hypotenuse. Let's look at an example. So here's our right triangle. We were given 8 millimeters, 15 millimeters, and then we're missing our hypotenuse, which is C here. I know this is the hypotenuse because 8 and 15 made the 90-degree angle, so C was the hypotenuse. It did not help make that 90-degree angle. So we start with our formula, and we plug in the two values that we know, 8 and 15. Now, since those are both legs on this triangle, they can both be placed in for A and B, and it doesn't really matter the order as long as they're both legs, then they're going to be able to be either A or B. So my 8 gets plugged in for A, 8 squared. My 15 got plugged in for B, 15 squared, and this is going to equal C squared, which we don't know yet. Now we actually solve this like an equation. So we're going to solve 8 squared, which is 64, and 15 squared, which is 225. Now I'm going to add those two pieces together. When I add 64 plus 225, I get 289. That's what C squared equals, but we want to find C. So how do we find C? Square root of both sides. That's going to get rid of your exponent, and that will tell us that the square root of 289 is 17. So C by itself would be 17 millimeters. Let's look at another example. We have 10 centimeters, 6 centimeters, and C. Our formula we're going to use is a squared plus b squared equals c squared. Now, do we have our b's, or our c's? Well, right here is c, so we know we don't have c. My two sides that I have are the legs, so that means they can be either a or b, and we can kind of place them in whichever order as long as they are legs. So let's say I said 10 centimeters is a, so we're going to plug that in. 6 centimeters is b, and we don't know c, so that's going to be 6 or c squared. Now we solve. 10 squared is 100, plus 6 squared is 36, equals c squared. Add those together, I get 136 equals c squared. It's looking like this answer is probably not going to be a perfect square, so I'm going to grab my calculator here to go ahead and evaluate what the square root of 136 is, since that's how we're going to figure out c. When I plug that into my calculator, I got a decimal. I got about 11.7. It was a very long decimal, but I could round it, either 11.6 or 11.7. That is about what c would equal. Let's look at an example where c is not the value that we're missing. We'll look at an example where we had something else that was missing. So here we're just given the lengths. We don't see it set up as the triangle. Our formula stays the same. What's missing in this one is our b. So when we go to plug in our values, this b is going to be the missing piece. So a, we're told, is 9, plus our unknown, equals 12 squared. So we're going to solve similarly, but obviously a little bit different since the missing piece is over here on the left. So let's go ahead and square the numbers we know. And now we have a little equation that needs to be solved. So to get b by itself, we need to get rid of our 81 by subtracting it on both sides. I got 63. So b squared equals 63. So to find b by itself, we're going to find square root of 63, which I'm guessing is a little bit under 8, but let's double check on our calculator exactly what it would be. Square root of 63. Oops, I did cube root. 7.9. That is our missing length b. All right, you guys, that's all I have for you today with Pythagorean Theorem. Check in with your teacher if you have any questions.